For this project, I implemented a planner that plans a sequence of actions for a character to take in order to reach a goal position. The planner searches for an optimal collision-free sequence of states using A star. A state consists of a position, an orientation, a timestamp, and a motion. The position is computed by multiplying the length of a motion by its velocity and adding the result to the parent state's position. The distance between this position and the goal is used as the heuristic for A star. The orientation of a state is based on the direction of the velocity relative to the parent state's orientation. The timestamp is when the state will occur, which is the sum of the lengths of each of the motions performed during the preceding states. The motions that the character can perform are walking, jogging, and jumping. The set of motions that the character can perform from its current motion are based on a finite state machine. The walking motion can be played at a slower and faster speed. The costs of the transitions are user-defined. In my examples, the costs are set to prioritize walking over jogging and jumping. To simplify collision detection, the character is represented as a fixed radius disk on the ground plane, and the obstacles are represented as rectangles. For static obstacles, new positions and the edge from their parent position are checked for intersections. For moving obstacles, samples of the character position and obstacle positions are taken between the timestamp of the parent position and the timestamp of the new position. Each sample is then checked for collisions. The character can also jump over obstacles if the width of the obstacle is less than the distance covered by the jumping motion. The main limitation is that transitioning between states results in unnatural movements. This is because the planner can only plan movement along a straight line. This means that the character must be quickly and unnaturally rotated to match the orientation of the next state and maintain a constant velocity between states. Future work could involve extending the planner to include 3D collision checking, a variable height terrain, and more complicated obstacle movements.